Good morning, viewers. This is Kasturi Day. Today I'm back with the question. The chapter, chemistry chapter of class 9 ICSE syllabus. It's atomic structure and chemical bonding. Okay. So let us start with this chapter. And before I start, I would request you to please to subscribe my channel and ring the notification bell, because as soon as new video is uploaded, it will notify you. Okay. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. Okay. And don't forget to meditate before you start your day. So for meditation, let us concentrate for just 1 minute, and then we'll start with a discussion. Okay. For meditation, think of a point of light. Think it is a point of energy which is coming onto you. Okay, you can think of a bulb also. You can switch on a bulb and think that light rays are coming on you, falling on you, like it is energy. The whole body of yours becoming energized. Your mind, your each and every body part is becoming energized, enthusiastic, and happy. You're feeling very much. Whatever work you do, you're getting interest. You're doing the job very enthusiastic and just as the time goes, it's going to stop here. We'll continue the discussion. Okay. And if you want more on meditation, please comment me. I will give you the link of any good meditation site. Okay. And it will help you in meditate and learn meditation. Okay. Very well mannered way. Okay. So let's start with the discussion: atomic structure and chemical bonding. Okay. So the first, the idea, okay, the atomic structure idea, that the matter is made up of smallest particle, which we now know as atom. Okay, it was first given by the smallest particle of matter is this idea was given by Maharshi Kannada in 6th century BC in India only. Okay, according to him, he told that matter consisted of indestructible minute particles. That means matter consisted of certain particles which cannot be destructed. Okay, and these are very minute particles, and so he named them as paramanus. Okay, now we call them as atoms. So he told that the matter consists of certain indestructible minute particles which are known as paramanus. Okay, and a paramanu does not exist in the free state. Okay, a paramanu could not exist in the free state, which combines with other paramanus to form a bigger particle which is known as anu. And now we call that anu as molecule. Okay, so there are different types of paramanus, and each exhibits some specific properties. So see, according to Maharshi Kannada in the 6th century BC, he gave his theory that matter consisted of some indestructible minute particles, which he named them as paramanus, and they could not exist freely. So they combined with other paramanus to form anu, a bit larger particle, bigger particle than the paramanus that were known as anus. And these have different types. There are different types of paramanus present, and they exhibit some special properties, specific properties. Okay, and paramanus We now call them as anus and atoms, and paramanus, which combine to form bigger particles, which we now call them as molecule. We call them as anu, but we call now as molecule. Okay, so this is the picture of Maharishi Kannada, Charya Kannada. He was the father of the atomic theory. Okay, now next we move on to the Greek philosopher after him, after Maharishi Kannada, the Greek philosopher Democritus. He gave a theory in 460 BC to 370 BC. He told, he called the paramanus as atoms. Okay, and atom came from the word, Greek word was the word was atomos, which means indivisible. Okay, from that we came, the word came atom. From atomos we call it atom. Okay. So he was the Greek philosopher Democritus. Now next is, after that, John Dalton in 1808. Picture is of John Dalton, the scientist. He gave a scientific theory about the structure of matter in 1808, and according to him, the postulates which he gave regarding this theory, that matter consisted of very small indivisible particles which were known as atoms. Okay, matter consists of very small and indivisible particles which are known as atoms. That means it cannot be divided further. Very small, very minute particles which cannot be divided further, and those particles are known as atoms. And atoms can neither be created nor can it be destroyed. They exist like that. It cannot be created nor it can be destroyed. And the atoms of an element are alike in all respects. Of one element, the atoms, the element which has different atoms, so all the atoms will have the same characteristics. Okay, but they differ from the atoms of other elements. Like, see, if we consider hydrogen, the atoms which make up the hydrogen element will be same. But if we compare the atom of hydrogen and compare the atom of oxygen, then the two elements are different, so the atoms will be also different. Atom of hydrogen and atom of oxygen both will be different. So atoms of an element combine in small numbers to form molecules. Okay, atoms of an element combine in small numbers to form molecules. And an atom of an element, as they cannot stay freely, so they have to combine with other atoms to form a molecule. And then atom of an element combined with other atoms of another element. If they combine with the same element, they form one molecule. Okay, and if it combines with the other element, atoms of other element in simple ratio, it forms a compound. Clear? Molecules of a compound. Okay. And if it combines with the same element, same atom of the same element, then it will be forming a molecule of an element of the same element. Otherwise, if it combines with the molecule, if it combines with another atom of another element, then it forms a molecule of a compound. Clear? Now, atoms are the smallest units of matter that can take part in a chemical reaction. They are the smallest units of matter that can take part in the chemical reaction. Okay. Now, according to the latest research on atoms, most of the postulates are incorrect. The postulates which John Dalton gave, according to the latest research, almost all the postulates were incorrect, except one. The one was correct, that is, atoms take part in the chemical reaction. Because in the later stage, we will see the atoms can be divided into much smaller particles. Okay. So atom is not indivisible. It can be divided. It is not so small that it cannot be indivisible. Okay. It can be created. It can be destroyed. We'll come later on. Okay. So all these things were proven to be false. Only one thing was true, one thing was correct, that was atoms take part in the chemical reaction. uh, the indication that the atoms are made up of subatomic particles which are charged. Okay. An indication came when it was proved, and it was not proved actually. I mean, at the first stage, but there was an indication that atoms were made up of some subatomic particles, and those particles were charged. Okay, and the condition under which this type of electricity was conducted, that was called the static electricity. So what happened? Electric current, we would see that was formed. It was seen that an indication was given that electricity was produced as the atoms were formed. When atoms are made up of some more subatomic particles which were charged. Okay, they are charged particles, and these produced some static electricity, and the conditions under which this electricity was conducted at the sea. Okay, now in 1833, Faraday showed that electricity flowed due to the flow of charged particles. Okay, in 1833, Faraday showed that this electricity was produced and they flowed due to the flow of the charged particles. As I told you, that the subatomic particles were charged, and these particles flowed from one point to the other. It flowed. So due to the flow of these charged particles, the electricity also flowed. Okay, and this was proved first by Faraday in 1833. Then G.J. Stoney in 1874, he first suggested the name electron for this electrical particle. As I told you that the electricity flowed with the flow of the charged particles. So as the charged particles flowed, so G.J. Stoney, he named these these charged particles which flowed as electron. Okay. And in 1874, he did so. Then J.J. Thomson, he showed the existence of electrons. Okay. He named G.J. Stoney's, he named these particles as electron, but the existence of electrons was proved by J.J. Thomson. And these electrons are negatively charged particles. Okay. Then E. Goldstein, he was a German scientist. He discovered some positively charged particles, and he named them as protons. Okay. Then James Chadwick, he discovered certain other particles which were neutral. Neither it had positive charge, nor it has a negative charge. So those particles were neutrons. So the protons, the electrons, protons, and neutrons came to be the building blocks of all atoms and were known as fundamental particles of an atom. Clear? Next, we move on to element. Now, what is an element? An element is a pure substance or a type of matter that can neither be formed nor be formed from nor decomposed into simpler substances by ordinary physical or chemical methods. Okay, so it is a pure substance or a type of matter. Element is a pure substance or a type of matter that can neither be created cannot neither be created or decomposed into simpler substances. The simpler substances cannot form these pure substances, or it cannot be decomposed into the simpler substances by ordinary physical or chemical means. That means some complex physical or chemical means can be used to break this matter, that is pure substance, or it can some chemical process or complicated physical process could create these elements, these pure substances. For example, carbon. Next is It is so because it cannot be split up into two or more simpler substances by ordinary methods like heating, breaking, or passing electricity. Okay. So, why we call that it is the pure substance and it cannot be split into this one? Because neither be formed of or not decomposed into simpler substances. It's because it cannot be split up into two or more simple substances by ordinary physical or chemical methods like heating, breaking, or passing electricity. We cannot break them or we can not form them also. Now, radioactivity. Radioactivity is a phenomenon due to which certain elements spontaneously emit highly penetrating rays. Okay. So radioactivity is a phenomenon due to which certain elements they spontaneously emit. That means they continuously they start emitting some penetrating rays. Those rays are penetrating rays are known as radiations. So that's why this activity, this phenomena is known as radioactivity. Okay. Now, radioactivity process of radioactive decay and high energy nuclear reaction can transform one elementary substance to another. Okay, that's why I told you that ordinary physical and chemical process could not transform, could not neither form any new substance, a new pure substance, or another they cannot be, the pure substance cannot be decomposed. But radioactivity can do so, can create a new substance, or it can decompose a pure substance. Okay. Next we come to atom. Now, atom is the smallest particle of an element. Okay, what is atom? It's the smallest part of particle of an element which exhibits all the properties of that element. Okay, it may or may not exist independently. It can exist independently or it may not. Okay, it takes part in every chemical reaction. For example, if a piece of zinc is taken and it's grinded into small pieces. So all the pieces which were grinded into small pieces, all the pieces show the properties of the zinc. Okay, it's a metallic nature, it's the chemical properties, all those properties will be found in the broken small pieces of the zinc. But if we grind them further, then also the particles will have show the same properties of zinc. A stage will come when it cannot be grinded anymore. The zinc particles will not be able to grind it anymore. We cannot subdivide them anymore. Okay, but they exhibit all the properties of zinc. Those indivisible particles of zinc, which cannot be divided further, those are known as atoms of zinc. Next, we come to discovery of electrons. Okay. So William Crookes in 1879, he studied the conduction of electricity through gases at low pressure. Okay. He conducted electricity through a cathode tube, okay, discharge tube, glass, the long glass discharge tube you used. In this, he filled a gas at low pressure and he passed electricity through it in 1879. And what did he do? What did he see? He sealed at both the ends of this tube and it filled with two metal electrodes. Okay, he fitted two metal electrodes in that tube and he sealed the both ends of the tube and he passed some electricity through this gas. Now, it had a side tube fitted with a stopcock, which was connected to a vacuum pump to reduce the pressure of the gas inside to a desired value. So what did he do? He took a glass discharge tube, two metal electrodes were there. He sealed both the ends and he pushed in some gases and at low pressure. Okay? And within that tube, he passed electricity. Now there was a side tube which is fitted with this discharge tube, and that side tube had some stopcocks, had a stopcock which was connected to a vacuum pump. Okay, And this vacuum pump was used to reduce the pressure of the gas which was filled inside the discharge tube. No? So to reduce the pressure of the gas which was present in that tube, and that yes, discharge tube, that was used. That was the pressure was reduced by this uh, stopcock. Okay, inside to a desired value, it can be reduced to. Now, when high voltage of about 10,000 volts was applied between the electrodes, the following results he observed at different pressures. Okay, so 10,000 volts were there, two electrodes were there, the gas was there, then a stopcock, a vacuum pump was there. Okay. So he observed that when the gas pressure inside is 1 atmosphere, okay, he first he proved that the gas pressure was in 1 atmosphere pressure, then no current flowed through between the electrodes. Then the pressure was reduced to 10 millimeters. Then the current started flowing. So he reduced the pressure. So from 1 atmosphere to 10 millimeters pressure. That time what happened? The current started flowing between the electrodes, and the colored glow is observed depending upon the nature of the gas taken. Okay. Now, when the pressure is further reduced from 10 millimeter to 0.01 millimeter, the glow between the electrons that disappeared. Okay. But the current continued to flow. Okay. So 1 atmospheric pressure, no current flow. 10 millimeter pressure, the current started flowing, and a glow came, colored glow came, which depended upon the gas which was used. Then the pressure was further reduced to 0.01 millimeter. The glow vanished, but the current continued to flow. And if a perforated anode is used, a faint greenish yellow is observed on the glass walls behind the anode. Just behind the anode, she had observed some faint greenish glow. This showed that some invisible rays are emitted from this cathode, which pass through the holes of the anode and strike the walls. These rays, these invisible rays, were known as cathode rays. Okay. See, this is the picture of the setup of the instrument, that discharge tube setup by William Crookes. So this was the discharge tube. He sealed both the ends. Two metal these electrodes were there, fitted inside it. The discharge tube was filled with gas, and electricity was passed from these two, electrodes. Okay, so he observes that some rays emitted from this cathode, and it reached the anode, and if it was perforated, if the anode was perforated, then he would have seen some green glow. He saw some greenish glow, okay, faint greenish glow, which was behind the anode. Okay, they showed that some rays emitted from the cathode, and these were known as cathode rays. Okay. So later on, electron was discovered by J.J. Thomson in 1897. In 1897, J.J. Thomson discovered this electron when he was studying the properties of the cathode ray. Okay, he was studying the properties of the cathode ray when he discovered these electrons. Okay. Now, J.J. Thomson, he constructed a glass tube which was partially evacuated. Okay, that is, much of the air was pumped out of the tube. Not much pressure was there. Maximum amount of partial evacuation was there because much of the air was pumped out of the tube. Then he applied a high electrical voltage, a high electricity current was flowing through this electrodes, between the two electrodes at the either end of the tube. Now he detected a stream of particles. He detected a stream of particles was coming out from the negative charged electrode, that's the cathode, and it moved towards the positively charged electrode, that's the anode. Okay. Now this ray, he called them as cathode rays, and the whole construction was known as a cathode ray tube. Okay, so J.J. Thomson discovered electron in this ray. Now, what were the properties of the cathode ray particles? The cathode ray property, the cathode rays, they traveled in straight lines. They were independent of the material composition of the cathode. Whatever the cathode is, the electrode was constructed with, independent of the material, whatever material it can be, but it traveled in straight lines. Then applying electric field in the path of the cathode ray deflected the ray towards the positively charged plate. Okay. So if we had applied some electrical field in the path of the cathode rays, then it deflected the cathode rays, they deflected towards the positive charged plate. Hence, cathode rays consisted as it deflected. So that's why the cathode rays were made of negatively charged particles. It concluded that the cathode rays are of negatively charged particles, and J.J. Thomson measured the charge by mass ratio, that is E by M. Charge is denoted by E, small e, and mass is M, small m. So E by M of the cathode ray particle using deflection in both the electric and the magnetic field. And he found that E by M is equal to minus 1.76 A minus 10 to the power 8 coulomb per gram. The cathode ray particle turned out to be 2000 times lighter than hydrogen. Okay, it was lighter than hydrogen, 2000 times lighter. Okay. So, properties of the cathode rays. Now, the cathode rays, they travel from cathode to anode. I told you they travel from cathode to anode, from negative electrode to positive electrode in straight lines. They cause a greenish yellow fluorescence of soda glass screen. On a soda glass screen was there. Then they caused, these cathode rays, they caused a greenish yellow fluorescence which is placed inside the tube. They are affected by the electric fields. If an electric field was there, they deflected towards the positive electrode. So inflected towards the positive field and deflected towards the negative field. Okay. It moved away from the negative field because the cathode rays are itself negative. So that's why negative, there will be repulsion. That's why they deflected from the negative field, but they inflected towards the positive field because positive is opposite to negative. That's why there is inflection. Okay. So this indicated that they carry a negative charge. Now, when a beam of cathode rays is made to fall upon a hard metallic target like tungsten, X-rays were produced. If cathode rays were made to fall on tungsten-like material, hard metallic targets like tungsten, they produced X-rays. And they could penetrate through matter much more. Okay. Then they cause ionization of gas. That cathode rays, they ionize the gas through which it passes. And the ratio of the charge to mass, that is E by M, of the particles constituting cathode rays remain the same. That is minus 1.76 into 10 to the power 11 coulomb per kg, or you can say minus 1.76 into 10 to the power 8 coulomb per grams. Irrespective of the nature of the gas which is taken and of the metals forming the cathode. They produce the shadow of an opaque object placed in the part and make a light paddle wheel rotate. Okay, they made a shadow, they produced a shadow of the opaque object if it is kept, then it produced a shadow if it is paid, opaque object is placed in their path, it produced a shadow, and it can make a light paddle wheel rotate. That means it can rotate a light paddle wheel. So this was the property of cathode rays. Next, we come to the conclusion by Thomson, J.J. Thomson. What did he conclude for this? That cathode rays consisting of negatively charged particles, now we call them as electrons, which means atoms of negative electricity. Okay, electrons means atoms of negative electricity. We call it now electrons, which was given by John Stoney. These negatively charged particles are the integral part of all atoms. And electrons have both definite mass and definite electric charge, both of which are independent of the nature of the gas which is used in the discharge tube. Okay, so it did not dependent on the gas which is present in the discharge tube, but it has a definite mass and a definite electric charge. Okay, and they are negatively charged and they are the integral part of an atom, and it was named as electrons nowadays, which means atoms of negative electricity, which was given by, this name was given by John Stoney, and this was concluded that they have by Thomson that they are negatively charged. So this much I'll stop, and next in the video I'll start with the electron properties. Okay, so go through this. If you have any doubt, please do let me know. Please write in the comment box. You can also refer to our email ID, that is kasturi74@gmail.com. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And please do subscribe and ring the notification bell, because as soon as a new video is uploaded, it will notify you. Okay? And please don't forget to meditate before you start your day. So thank you for joining, and have a good day.